And the methods, so the elevator is very likely having some sort of state that it can, set stationary, move, and so forth. And it's very likely that it has a set of methods that could be used to control it, right? So we can say set direction, so the elevator can move in different direction. We can say move, right, according to the direction. We can also say stop. We can say service, and so forth, right? So this is a smart object which does a lot of things directly related to the control of machinery or device, right? So this is relatively simple to program, and each method, such as set direction, move, stop, service the device, and things like that, can be done, very, in a relatively simple manner, right? We have pretty clear idea what these things could mean. As long as we are, using the right modifications to the state of the elevator and program it accordingly, we can achieve some pretty good results. It can also keep track of the current floor, right? Current floor, right? And it can have other types of attributes. For example, an array list of riders or passengers, and with each stop and move and so forth, it can notify the appropriate objects about the events that it should be able to generate. At the same time, the question is, what about the statistics? If I want to keep the stats about the elevator movement, which should help me with regard to its servicing, its inspection, its just general idea regarding the load, right? So I want to know perhaps how often does the elevator change the direction, right? How many floors does it travel per day, per its life cycle, per each period between the services? How often do we service these elevator cars and motors, and how often we do the inspections? All of this statistical data is really outside of the realm of the device, the actual operation of the device, right? In other words, we're trying to measure, right? Measuring operations that this device is involved in is sort of like a secondary job compared to all of the primary operations that we consider with respect to an elevator. So the question is, do we take all of the measuring and make it part of the implementation over here, or do we keep it separate? And so here's the proposition. If we incorporate everything inside the elevator, the class just becomes too big, too difficult to deal with, overcomplicated by the compounding of the general operation and measuring and collecting the statistics. So here's a possibility, right? The possibility is to create a class named interface elevator. Okay, When I have this iElevator, which is an interface, I can simply take, right? I can take all of these methods right here, which I was thinking about, and make it part of the interface, right? Just move the operations into the interface, and then draw the interface like this. Of course, the interface has no data attributes, right? It only has abstract methods, and this is the interface. In fact, we can specifically say in our in our UML, we can say that this is an interface, right? So let me make some adjustments here so we can keep everything clean, right? So I can say this is an interface right here. So this is an interface, and I prefer to call my interfaces with an uppercase I in front of them, so I can easily recognize them in my software. And of course, we can have the elevator implementing this interface, right? So I'll just use simple generalization relationship here, but this is implementation, right? Elevator implements each method here. So first I separated the operations, and typically when I use UML that combines the interface and an object, or class rather, which implements that interface, I typically, in my practice, I do not repeat these methods. I typically keep the method section empty because it really isn't necessary. Because if I say that the elevator implements the interface, it's a clear idea that all of these methods have to be present over here, right? So this is sort of like a shortcut to make your UML diagrams cleaner. Is basically specify methods in the interface box and simply leave them blank over here. So if I decide to add other set of methods to my elevator, this is fine. I can do that and list them over here. But if all I do is simply implement this set of operations, I can keep that blank. So then, so far, this really doesn't change much, right? Rather than perhaps now what the elevator bank needs to do is perhaps instead of storing collection of the elevators, it can store the collection of the elevator interface references, but I won't change it just yet. Instead, I can create another class which is called elevator proxy, which does exactly the same as the real elevator, and basically it implements the same interface, right? So that's why I keep its method section also blank, because it just says implement the same elevator. The idea of the proxy is that instead of implementing each method realistically, instead, what the elevator proxy does, it basically keeps a reference to the real elevator, and in the world of proxy, the elevator becomes the subject of the proxy, right? So we can say that over here, proxy has the subject, right? And this subject is indicated by this line. So the elevator proxy has a reference to the real elevator. In this way, as an example, what I can do, instead of associating the elevator bank directly with the elevator, instead associate it with the proxy, right? And say it's the array list of elevator proxy objects that I will have inside of my elevator bank. However, I can start thinking about this elevator proxy as being my proxy, right? So what happens? So this is like a comment in our UML diagram. So I'll just kind of highlight this different color. So this is not a separate class. This is just a comment which I would like to attach to this object right here. Right. So this is a comment which I attach over here. So this is a measuring proxy, and what this measuring proxy does that, well, first of all, the idea of the proxy is that when the elevator bank calls methods such as move or set direction, what elevator proxy does is basically delegates the call to the real elevator, to its subject. It basically says, hey, move, set direction, and so forth, with each call from the elevator bank. But at the same time, this is where, so when I begin to implement these methods inside the elevator proxy, this is where I can add my measuring, right? Because the elevator proxy, and if it's a measuring proxy which wants to, update statistics and so forth, what it can do, it doesn't care what do we do to move, right? It doesn't care what do we exactly do to set the direction. It just needs to know that we actually have a request to move and have the request to set direction. And so it can update its own attributes over here, which will essentially capture the statistical data, right? So in other words, what I can do with this proxy implementation is that all of these measuring, attributes, the actual statistics, all kinds of, counting variables, variables that accumulate the distance traveled by the elevator car and other statistical information I want to capture, right? So I'll just simply say stats, all kind of stats. I can keep inside my elevator proxy, right? So each single call to any method which allows us to operate the actual device, all of these methods that we decide to implement by the real elevator. Inside the proxy, we simply delegate all of the work to the real object, to the real elevator. But at the same time, inside proxy, we update stats every time we get a call to any of these. And then I can add another method over here, or set of methods, where I can say get stats, right? So that I can have a whole bunch of methods which allow me to access the statistics wherever I want, right? Whenever the rest of the system may say, let's display statistical data and basically communicates to the elevator bank. Let's collect all of the statistical data. The elevator bank can basically go through the array list of existing elevator proxies and ask each single one, give me your stats. So therefore, somewhere here we can have method similar to this. We can say, get stats right here, and so someone can call this method, and we can iterate through the list of existing elevator proxies. And this time, of course, when we say get stats, we don't go to the actual elevator. It's the proxy that keeps measuring, that keeps information. So the achievement here is that all of the measuring activity is taking place outside of the implementation of the actual device, which only implements the actual operations, right? So that's a design idea which is called, so now we can give it a real name. This is a proxy design pattern demonstrated with our semester project level discussion that we discussed before, that we have an elevator bank which stores a collection of elevators, but at the same time, we could have done this. We could have employed all those statistics directly inside the elevator. We would not need the elevator interface in this case, and we can just write all of the code directly inside the elevator, which unfortunately mixes two different types of operations, right? So we just like we said, measuring is really different layer, different idea compared to the actual operation. So the proxy design pattern allows to decouple these two activities: operating the physical device and at the same time measuring the stats and collecting the stats and eventually gathering the stats or retrieving the statistical data, right? So this is a quick demo on that on this proxy design pattern.